On air. All right, so we're live. Cool.
Dope.
Dope. And I guess it's just us two today, right?
Yeah, I think so.
Cool. Let's blow through this. We got it. Any questions from the homework?
I didn't really look at part 2 yet because I
Yeah.
had to go do another project. But if it's like part 1, then
Yeah. It's basically like part one. It's asking you about one thing you didn't go over in part one was the type one and type two errors. Do you know what those are yet?
yeah, I know those.
Okay. And then it just wanted you to create a study and basically just do everything we already did.
Oh, okay.
Okay.
That's not too bad then.
All right. Well, I'm gonna go and open up the group quiz. I didn't have any questions really. It's straightforward. I feel like
Yeah, I
today,
didn't think I'd have any either. It's pretty straightforward.
I feel like today might not be too hard. We'll see.
Yeah, let's
So,
hope. How'd the test go for you?
really good actually. I got an A on it. What'd you get?
Yeah, me too.
Yeah,
I
they'll
was
probably
really
get hard.
nervous about it, but
Huh?
I was really nervous at first just because I haven't taken one of the tests in this class yet, so I just didn't know how it'd be. But
Yeah,
in the end, it was good, so
yeah,
okay.
yeah. It was good. I like this online
Yeah,
class actually. I don't know. I've heard it's
don't
better.
mind it. It's
I've heard it's better online than it is like in class. But then again,
I can see that though too. Like
it's just more convenient, you know?
exactly.
Because like it doesn't matter. We don't have to meet in the same spot. We just meet up online, you know?
Yeah, which is
Are you in
really
the
nice.
Romney right now?
Huh?
Are you in the Romney?
Yeah.
I can tell by
Yeah.
that picture of space.
Yeah, the space, yeah. Yeah, I have to go to like the black holes exhibits thing in the planetarium tonight for class.
Oh,
So,
what time is that?
it starts at 7. So I have to go. I'll walk over and buy tickets at like 6:30 and then
That's
I
cool.
have till 7 till it starts. So, it's not bad though.
Yeah. All right, I've got it pulled up.
I did 21 questions, not too bad.
Yep. All right. Which hypothesis involves equality?
The null.
The
Or
null
is it the
hypothesis. Well, no, no, no.
Yeah,
Yeah, I think it's the null.
yeah. I was thinking it could be the true for a second, but I don't.
No, I didn't even read about
It's
that. Yeah, this is the
yeah, I
null.
didn't either.
I didn't really necessarily understand that. I guess I understand that more when I'm reading it right now, you know? The null
Yeah,
hypothesis is
exactly. Yeah.
equal to something.
So it says here that the equal hypothesis versus non-equal is, yeah, it should be just the null
The null.
hypothesis.
All right, just a second.
Did you watch the videos?
No, did you?
Yeah.
Hmm.
Not
Were they any good? You're on video, so you better
pretty
say.
much. It's pretty well. It's pretty much just like a summary of the chapter, really.
Okay.
So if I'm short on time, I only do the videos and I don't read the section.
Oh, really?
Yeah,
Smart, actually.
it's been nice.
I'm taking a note on that real quick. Okay, cool. Moving on. The p-value. Remember that the p-value is the probability of obtaining a sample statistic as at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? The null.
Yep.
The alternative is the alternative. So,
Yeah. You always assume the null is true unless given information otherwise.
yeah.
Okay. Suppose the null hypothesis is a weird U thing. I forgot what it's called. Is equals 10.
All I remember is sigma.
Yeah, sigma. I think that is sigma.
That's
No,
not
it's not.
sigma.
Sigma
Sigma
is
is the
like
standard deviation. This one's something
yeah,
else.
yeah. It's not alpha or beta or sigma. That's all I know. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
The one with the equal sign with the slash through
Yeah.
it.
Yep.
Which of the following represents the alternative hypothesis for a left-tailed test? The first one.
Yep.
Right-tailed. Oh, second one. Oh, these are hard.
I know, man. I don't know if I can make it.
Yeah.
Okay. Remember, same thing. Determine the outcome of a hypothesis test by comparing p-value to level of significance or sigma. No,
Wait,
that's
would
alpha.
result in failing to reject a null hypothesis. Oh, so it had to be greater. So the first one?
I think so. Although, why would it have to be greater?
So, so if it's like 90%, that means 90% of the time that you're gonna find that number if the p-value is 90%.
Okay.
If it's like 0.01, that means the probability is super, super small that you're even gonna ever have that number happen. And so
Okay.
let's say, yeah, if we set like the level of significance at 10%, and then we get like 3%, it's below the level of significance. So therefore, we're going to say that it's highly unlikely, and we're going to reject the null hypothesis.
Oh, okay. So the p-value is greater than alpha, therefore having a high significance. Therefore, okay,
Yep.
that makes sense.
Which relationship would result in rejecting it? The opposite. It'd be less.
Less. So the second one.
Yeah.
Okay, insurance companies are reviewing its current policy rates when originally setting the rates. They believe that the average claim is about $1,500. They are concerned that the true mean is actually higher than this. Use the information for the next two questions. Which of the following would be the appropriate alternative hypothesis?
I'd say the third one.
Yep.
Okay. And then which of the following would be the appropriate null hypothesis? The first one.
Yep.
Cool.
Okay. The insurance company randomly selects n equals 40 claims, calculates a sample mean of 1650. Use this information for the next three questions. The insurance company assumes the distribution of sample means is normal. Is this a good assumption?
Yeah, I'd say it's large. The sample size.
I think 40 seems large to me. Probably just the first one.
I think it's funny how it's like totally up to our discretion. We're just like, meh. For me,
I know, right?
If it's over 30, I'm like, I guess that's a big sample size.
Yeah, that's what I do too. Is 30 is generally the cutoff. Like 29,
No.
pushing it. But 30, yeah, okay. That's like all statistics is though. Is like
I know, right?
numbers to your will.
It's kind of like discretionary, like the level significance. Just choose a number.
It's so true though. No, not significant. No, definitely.
Yeah, seriously.
That's really funny, actually.
Yeah, seriously. Okay, what theorem or law like justifies your answer to the previous question? Law of not large numbers.
Law of large numbers.
And we know if we get that one wrong, it's the central limit theorem. So there we go.
There you go. Which the following is the test statistic as defined in the lesson?
So I remember the test statistic being a z-score.
Yeah, that's what I remember too.
It's just testing to see if it's, yeah, whatever.
If it's, yeah. So it's just
smaller or bigger than the p-value is a test statistic, you know?
Yeah. Which is just basically what it is away from the mean. So it's z-score.
Yep. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with a hypothesis that the parameter mean equals $150 and that the alternative hypothesis is that the parameter mean is less than 150. Okay, she will use a level of significance of 5%. She then takes a random sample of 36 sales receipts from her store and computes that the sample statistic mean is $144. Okay. What is the z-score associated with this test? All right, get your calculators out.
No, dang it. I hate it when I forget my calculator, so I only have my phone.
Yeah. So for this one, we don't know the standard deviation already, do we?
No, are we trying to find the standard deviation?
Oh, no. It says with standard deviation of $40.
Oh yeah, in the beginning, yeah.
It's just weird. It's not usually given to us like that. Like in
Yeah,
that.
I know. I know. Okay, so that's not too bad. So you just do 144 minus 150 divided by 40 divided by the square root of 36.
It's 6.
Is that 6?
Yeah.
Okay.
Whoops.
I believe you.
Well, the square root of 36 is all I'm saying.
Oh, okay. Yeah, okay.
I got negative 0.9.
Okay.
Oh, 3 decimal places? Maybe I'm wrong.
Well, it might just say that. Well, that's it. It did that on the test too.
Yeah.
So let me see.
Because for the numerator, I got negative 6. And then for the denominator, I got 6.666667.
Yes, I got negative 6 as well. Divided by. So, I don't think I can do this on my calculator. Where's the square root button? Yeah, we'll just go with yours. I can't find it on the phone.
Oh.
Yeah.
If you have a smartphone, you tilt it to the side.
Yeah, I did, but it still doesn't have a normal square root button. Oh yeah, it does.
Oh.
There it is.
It's the square root when it has the 2 right
Yeah,
there.
I just didn't see it. Okay.
What is the p-value associated?
What did you get?
Negative 0.9.
That's what I got too.
Okay, and it's a left tail, so I'm going to plug that into the probability applet. And then if you just highlight to the left, I get 0.1841.
That's what I got too.
What inference would you make about the null hypothesis for this problem? Well, it's 0.184 is the probability, and it's 0.05, so you don't reject it. So you reject to reject it. You fail to reject it.
Yep.
Okay.
That's so weird.
I know. It's a double negative. I hate those.
I know, me too. Okay. What is your conclusion for this problem? 1, we have insignificant evidence that the true population means 150. We have sufficient evidence that the true population means 150. We have insufficient evidence that the true population means less than 150. We have sufficient evidence that the true population means less than 150.
The third one.
Yeah, because we're rejecting to reject it. So therefore it's...
And you can never confirm the null
Yeah.
hypothesis.
You can only not reject it.
Yeah.
Yeah, exactly. Hence the reason we have double negative instead of a
I'm just going to say exactly, but I kind of didn't follow it.
Well, it's like because you can't confirm it, you can only not reject it.
Right. Yeah. Yep.
Which
That's the closest to confirming you can get is not rejecting it.
Exactly.
Mm-hmm.
It's like science. You don't actually prove anything. You just don't disprove things or disprove them.
Yeah.
It's funny.
So that's that. There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? It's type 1, right?
Yeah.
Because type 2 would be failing to reject.
Yep.
Okay.
A researcher decided that instead of using a level of significance of alpha equals 5%, he will use 1%. Which of the following will be true? Probability of type 1 error will increase. Probability of a type 2 error will increase. Probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid. Probably that one.
His experiment will be more scientifically valid. I think it's the second one actually.
I did too. I was just kidding about that.
Oh, okay. Sorry.
That doesn't change anything about the validity of this experiment.
Okay. I couldn't tell. Yeah,
Although
I don't have the video up right now. I just have the screen, so
okay.
I didn't see your.
That's good. Although I do think this is a funny question because this proves like, yeah, his level of significance is 100% his choice.
Yeah, seriously. You use 0.01. All right. If
Okay.
sigma, no, what is it? Alpha?
Yeah.
If alpha equals point level significance is 5%, compute the probability of committing a type 1 error. Type 1 error occurs when you fail to, oh gosh.
I don't remember.
Type 1 error, wait, I gotta read this. Rejecting the null hypothesis, even though it's true. So would it be 95% or 0.05? I mean 5%. Okay, even though it's true. To be true,
I think it's 95.
Why do I have trouble wrapping my head around this crap?
I do too.
Compute the probability of committing a type 1 error.
Hey, one sec. I'm gonna go buy tickets really quick. I'll be back.
Yeah. 5%.
Okay, perfect. She said it was too early.
Oh, okay.
Okay, so
it'd be 5%. Because 5%, that's only 5% chance that you're gonna reject it anyways.
Exactly, and oh gosh, where did I read it? How did it word it? Yeah, because the 5%, that's the level of significance, and the level of significance is like the chances. If that makes sense.
Yeah. Don't submit it yet. I already submitted it. We got one wrong. It's the central limit theorem for 13 because it's dealing with the distribution.
Oh, the shape, not the, yeah, that's right.
So
13.
Let me pull it up again, and then if you just let me know what the answers are. And
yeah, I got you. So the 1 and 2 are true.
Yeah, thanks.
Got you. 3, oh, just let me know when you got it up.
Got it. Null, right?
Okay. Yeah.
Okay.
The null hypothesis. 4 is also null hypothesis.
Okay.
5 is the u is not equal to 10.
Okay.
6 is the u is less than 10.
Okay.
7 is greater than 10.
Okay.
8 is p-value is greater than alpha.
Okay.
9 is p-value is less than alpha.
Okay.
10 is the average claim amount is greater than 1,500. 11 is the average claim amount is equal to 1,500.
Okay.
12 is it's a good assumption because sample size is large.
Okay, back to 13. Central limit theorem.
Central limit theorem, yeah. And then 14 is the z-score.
Okay.
15 is negative 0.9.
Wait, did I submit it with negative? Yeah, it'd be negative. That's right. Okay. And then it's 0.186 or something like that?
184.
Ooh.
Yeah, negative 0.184.
Oh, okay.
Well, technically it's also positive 184.
Wait, just a second. It's not going to be negative. It's going to be positive.
Is it positive?
Yeah, because... is it? No, wait.
No, because
No, it's a percentage. It's not going to be negative.
Yeah.
It's 0.184, yeah.
Is it just 0.184? Okay.
Yeah.
Better. Why did I put a negative there? 17 is fail to reject the null hypothesis. 18 is we have insufficient evidence that the true population mean is less than 15 tens.
Okay.
19 is type 1. And then 20 is probability of a type 2 error will increase. 21 is 5%.
Okay.
All right, I'm going to save. Submit. Okay.
Did you get it?
Let's see here. Yep, 23 to 23.
Cool. Me too. It looks like we're good.
Awesome.
All right.
Done deal. Took like 20 minutes.
Yeah. Yeah. Yeah, that was really fast. It was pretty easy too.
Yeah, that was a good
So
week.
I'll post this on the community board for Jacob,
Okay.
and then I'll just submit the assignment like Jacob normally does. So
Awesome. Sounds good.
cool. Well, have fun
Thanks,
at the
man.
black hole thing.
How it goes.
You did it.
Yeah, you too.
Okay. Have a good one.
Catch you later. See ya.
Yeah.